you know, acronyms are always so strange, so I'm sorry for QUELCE. I keep wanting to say quench, and but got interested in the idea of what do we do about cost overruns? And there's this famous Parka presentation, if you all are familiar with the group, and about cost overruns, and they said a very large percentage of the cost overruns are due to poor estimates. Yeah, I was thinking about it with my colleagues, and it came to the notion that we know a lot about programs and about the decisions that we have to make very early in the life cycle, but we don't know precise answers, and we make assumptions, and we don't say that we assumed something. So what could we do if we wrote down the things that we knew might change? And then along came the POPs, the program probability of program success metrics, from the Army originally, and the Air Force and the Navy both adopted it. They've probably taken it farther. This picture is from the Navy POPs criteria handbook, and it shows you how many times you are supposed to revisit an estimate in DoD 5000 speak. And every single one of those diamonds represents when you have to recreate an estimate. Every single one of the little triangles represent where you need to revisit the estimate. So you can see it's about 18 times. So what did we do with QUELCE? The idea was, let's see if we can insert some evidence of this uncertainty at various stages in the process of producing an estimate. Didn't have to do very big changes. If you look on the left-hand side, we're saying we're going to quantify evidence of uncertainty. But you're going to document these first two things, the information from analogous programs. You're going to document your proposed material solution, and then you're going to say, what are the potential change drivers? What could we have made an assumption about that we haven't really quantified? And you can see the areas there. There are things about the system trade-offs. There are things about operational capability trades that I'm going to make. There's a technology development strategy. And oh, by the way, if you put a fourth one, there's the program contract trades as well. Okay, so there are a bunch of things in where you're making trades. And we want to create plan specifications and estimates. And then in order to keep track of all of this, we use something called a Bayesian Belief Network. And if you remember probability theory from when you were in college, you read about Bayes, who said, rather than this just a pure frequentist idea, I can think about problems like urns, and if I have some information, how do I use the reduction of uncertainty to make better forecasts? So here's the overview. We've developed a 5-step method. The first 2 steps are literally about reducing the scale of the problem, and the last 3 steps are about the actual quantification and creation of the estimate. So we start off with helping people identify the potential for change. The POPs criteria, this POPs guidebook from the Navy, is actually a good source of saying, these are things you ought to be thinking about that might change, might represent risks for this stage of the project. So you could use that as a guideline. We're trying to build this repository of other potential guidelines from existing data. Then we ask the people who are in the program to write down what they think the potential changes for this program are, and we create this driver state matrix. Then we use, like EPEC talked about earlier, a dependency structure analysis to say, if something changed, it might cascade and cause other changes. So let's represent that with a DSM, a dependency structure matrix, and then try to reduce the complexity. And then we build this Bayesian belief network. And fortunately, there are some tools for these things. Once we've done the Bayesian belief network and have the probabilities, we use that to feed cost estimation relationships. For example, the picture up there represents Kokomo, which is a software cost estimation tool. I don't care what the CER is, but we can use multiple cost estimation relationships to do this analysis. And then the final step is, I did this variance, I got this big range However, maybe I ought to think about some certain scenarios of change to see if it moves it outside the range of the estimate that I've got. So for example, let's say I can't accomplish a TPM. What's that going to do to my program? I have a subcontractor who can't do the job and I have to replace the subcontractor. What does that do to the estimate? And these are things, by the way, that have really happened. They're not imaginary. So we did a review of a large program, a retrospective. Go look at a history of a program, and let's see if we can recreate the estimates. And can we identify the change drivers? So we can say that all of the changes that did occur that we thought had a large consequence were visible in documentation early on in the project, way before they were hit. However, as you might expect, somebody made a point assumption that said it's going to be one or the other. We also, so every aspect of the uncertainty appeared somewhere. There were cascading effects that were identified and could be identified by a group of our own staff who were expert in this particular program and said, yes, that affected this and that affected this. So we could see this cascade. However, the original program basis of estimate wasn't documented. It had disappeared. So we didn't know what the estimate looked like. We could only see estimates for block releases of the program. And when we did QUELCE based on a block release, we could see this business about that the range was larger and that scenarios reduced the range of the estimate but would move the median value of the estimate. We couldn't see the whole aspect of the program because we didn't have the original basis of the estimate. But we did see, as a result of the scenarios, the basis for mitigation strategies. Next thing is the pilot program that we did this past year. This is a sort of an interesting one. There's a prior estimate. They're now mid-life cycle and they're doing a modernization. We did work with them. We oriented the staff to the program. We reviewed their change drivers and sent back a list of what the change drivers were. We identified 32 change drivers that were critical to this program. We learned a couple of lessons in the process of doing this. That sort of gives you the idea how hard transition can be sometimes. There's a tendency for a program to think an estimate means cost analyst. And that's really not true. An estimate means I've got subject matter experts in engineering giving me what the trades are. So that's a key factor. The scope and effort of the pilot was severely constrained because of this problem and the length of time that we were given, because the subject matter experts are a valuable resource, and so they really want to be very tight with that. And we need better transition materials. Well, that's not really a surprise either. All right, what's going on? What did we accomplish in FY14 then? First of all, there were the two challenges. Collect the history and classify it, which we can do. Assist experts to search and classify potential materials. We've done a pretty good job with that. Collect and create a taxonomy from the Naval POPs criteria with extensions and cover more detail. We've done really well with that. Assist the experts now to how well can we calibrate experts to tell us what their range of uncertainty is. So there's a tendency to be over-optimistic in your judgment. And we've done some work on calibration of experts to keep them from being over-optimistic. And we are trying to analyze the group effects of that. So we've coded a bunch of artifacts from programs and documented a number of change drivers and started to build sort of a classification schema for this. So the taxonomy stuff was the main thing there. Taxonomy might not be the right word, but the classification of change drivers. So the technical challenge that existed was there were too many change drivers for a group of experts. You need to narrow the range of classification to a subgroup of the audience that you have. So there were some funny things like that. Anyway, we have gotten very far with the classification technology and teaching people how to get the right range of estimation for those individual ones. Now we're looking at a few remaining challenges. The first thing I think that's on the table right now is to provide a clear business case. This started off as a pre-milestone A estimation. It's absolutely clear we don't care whether it's pre-milestone A or modernization or what. We can still add value. We need a real case history or a real pilot program where we've got enough time to do it. We have to build some transition artifacts. So we've built tools. We have a tool for the Bayesian Belief Network. We have a tool for the Dependency Structure Matrix. We know how to glue between the Bayesian Belief Network to the cost estimation relationships, but I don't know how to teach you how to do those things yet. We have to reduce the cost of building the repository of change. It's too expensive to do 200 documents by hand, so we're looking at machine learning to go filter documents of change and pull the information out. And we need to improve our confidence in the repository. We think there's an opportunity to expand this method to additional risk management. We're going to think about what that would mean. I don't know exactly yet, but it certainly is definitely a powerful way of not only doing the estimate, but providing you the documentation to get through the CAPE so that they believe you have a valid estimate. And that's been one of the problems for programs, is if you go to the CAPE and you're trying to pass your estimate and they say, we don't believe your estimate, you now are looking at anywhere from 3 to 6 months before you get back through the CAPE to get your estimate approved, and that delays your whole program. So having a clearly documented estimate with substantive validation there, it makes a big difference as to how long it takes you to get through the process of having that independent estimate. And I think I only put my name and Bob Stoddard's down, but we've also had Dennis Goldenson and Jim McCurley working on this. There's a wealth of information about uncertainty, and we know how to use it. Thank you.